So in this video, we're programming the active harmonic filter, or AHF. First of all, we enter the password. The default is 080808. Log in, and we'll take a look at our system parameters first. So the first parameter is our operation mode. Now this is capable of doing harmonic correction, that would be H. It can do power factor correction, and that is Q. Q is for kilovars, adding kilovars to the system to correct for power factor. And finally, it can do load balancing. So we need to let it know how it wants to address those things. So for instance, let's say we wanted to use the unit's 90 amp capacity to correct for harmonics. And then if we had any left over, we would use the unit's capacity to correct for kilovars. And then if there was still capacity left over, we would use the unit for load balancing. Then we would select H for harmonics plus Q plus B. So it addresses the first item, then if there's things left over, then the second item, and finally the third item. In our case, the most important thing for us in this particular application is correcting for power factor. So we're going to select Q plus H, and therefore it will add kilovars to reach our power factor goal. And then if there's capacity left over, then we will apply that to harmonics. Now the power on mode can be either manual or automatic. And next we're going to look at the CT location. If your CTs or current transformers are downstream of where the Pure Power 3 is connected, then they would be on the load side. If they're upstream, then we're going to see the supply side. So the load side would see what's actually going to the load. The supply side would see it after correction by the active harmonic filter. Now the next thing we'll look at is the total capacity. This is a 90 amp unit. If we had 3 units all in parallel, then we would put in 270 or 3 times 90, and then this unit would know that it's simply supposed to supply 1/3 of that amount. Then we'll go page down. Our compensation mode can be intelligent, or it can be sequential, or all. We strongly recommend you go with intelligent. Intelligent gradually brings the harmonics into the system, tests for resonances, and it looks to make sure that the system is going to remain stable. Now, if you have a very fast changing load, say an arc welder or something, then you may need to go to sequential. But if it works, we would recommend you stay with the intelligent. So next we'll go to our current transform ratio, and this is pretty easy. In this case, we have a 1200 to 5 CT, or current transformer. So we'll just touch that and we'll enter 1200 for our CT ratio, and then hit OK. Now let's page down, and the next thing we're going to look at is our PT ratio. If you hook this up to 480 or 208 or what have you, then there are no PTs, so it would just be 1. And if you hook it up to potential transformers, then you'd put in that ratio so that it knows. Next thing will be target power factor. So the target power factor in our case, let's say you wanted it to be 94%, you'd put in 0.94. And therefore it's going to search for that, and then once it reaches that, then any excess capacity it's going to use for harmonics. We can select this unit to supply kilovars or to use kilovars. To supply kilovars, we put it in capacitive mode, or to use kilovars, we can put it in inductive mode. It can do both. Now we hit page down. Some of these are fine-tuning parameters. We're going to go down to the next screen that's going to be important to us, and that's your harmonics compensation setup. Now in this case, you can choose which harmonics you compensate for. In this case, you can see we're compensating for 100% of the 3rd, 5th, 7th, 9th, 11th, and 13th, and then 0% of everything else. Now, in a 3-phase system, you're not going to have triplet harmonics. So what you're going to do is set your 3rd, 6th, 9th, 12th, anything divisible by 3 to 0, because you don't have those harmonics available. In a 6-pulse system, a standard system, you're generally going to want to correct for the 5th and 7th harmonics. Those are most important. The next harmonics will be the 11th and 13th, and then your 17th and 19th. And if you correct for those harmonics, generally that is sufficient to provide pretty clean power to the system. Let's say that we want to change our third harmonic. In that case, we'll just touch that. Maybe we want to compensate for 80% of the third harmonic. We can just go ahead and enter that. We would encourage you in general to go with 100% of the 5, 7, 11, 13th, and 17th, 19th. Okay, we're going to go back to settings. It makes us log in again. Since we already had the login password, we just hit OK. Now, the first thing here is going to be monitor parameter settings. You can put in an external display on this. If you put in the external display, you're going to have to put that address and the log and the baud rate for the display and select which language you want there. Next, we'll go back to the main screen, and you can see again the load current on the right and the grid current on the left. So the load current is uncorrected, the grid current is corrected. If you want to turn the unit off, you just hit power off, and it will ask you if you're sure. If you want to turn the unit on, then you just push power on, and it'll ask you if you're sure. Very simple. And the harmonics will be gradually corrected because of the intelligent mode. In intelligent mode, it gradually does this as it's checking for system resonances and any other problems in the system. So we're going to speed this up a little bit. It takes about 1.5 minutes, but we will speed it up so that you can watch this unit correct for the power factor in order to provide a very clean power to the grid. Now you can see that we've got some 20% total harmonic current distortion on the load, but our grid is way down in the 2-3% range, which is extremely good power. All right, we're on the main screen again. This time we're going to look at data. So we have a number of things to look at. You can see your voltage, you can see your current, and you can see your power analysis. So let's look at the current first. The compensation current is what comes from this unit. And you can see the values there, or you can see it on the current waveform. So here's the current waveform on L1, here's the current waveform on L2, and here's the current waveform on L3. If we go back and look at the current again, let's look at the grid current this time. This is after correction, so there's the current, the power factor, and the total harmonic distortion. And we can see here the waveform, or we can see the harmonic spectrum. Now let's take a look at the current and go to load current. So this is the load current before it's corrected. You'll notice that we have quite high harmonic distortion, but here we see the current, the power factor, the distortion, and we can also look at its waveform or the harmonic spectrum. So let's select power analysis now. Notice that you can see your grid and you can see your load on the same screen. So we have our apparent kVA, we have our apparent kilowatts, and we have our reactive kVAR, and then we have cosine phi, which is your power factor. So you'll notice that the power factor is pretty good right now. So this is a brief programming video for the active harmonic filter, or AHF. This is one particular installation and won't necessarily apply to all scenarios. If you have further questions, please check your manual or call your electrical distributor for more information.